Okay. Hi guys, this is Saurav here and welcome to Online Pathshala. I'm very sorry for the late start. We had some technical issues and we resolved it very soon. And welcome to Online Pathshala. This is Saurav Goswami, your master teacher. And this session is the fifth session of all the sessions that we have conducted until now in the topic of liquid solutions. This session is about the elevation of boiling point. We have until now discussed only one colligative property, which is the relative lowering of vapor pressure. And मैंने आपको बताया पहले कि the relative lowering of vapor pressure's meaning is that when you add a solute, the vapor pressure drops and the solute has to be a non-volatile solute. Colligative properties mean that those properties which are affected by the amount of substance rather than the nature of substance. Okay, so if the nature of substance is alike, means two substances if we take which are non-ionizable, equal number of moles, then the nature of solution, property of the solution observed in terms of vapor pressure, in terms of boiling point, in terms of freezing point, in terms of osmotic pressure, will all be alike. This session is very important because this talks about a very important phenomenon that we observe, which is known as elevation of boiling point. Okay, ये elevation of boiling point आप लोगों ने भी observe किया है, but you might have missed out. Okay, so good evening guys, good evening to everybody, and let's talk about what is elevation of boiling point. पहले तो ये हम जान लेते हैं कि what is boiling point. You might have seen that you take a coffee maker. This is a transparent coffee maker. When you take a coffee maker, put it on the plug it in, you'd see that after a while the liquid starts boiling. Okay, so what is boiling? This phenomenon is when the vapor pressure of the solution becomes equal to the external ambient pressure. For example, the external pressure right now is, let's say, 1 atmosphere. The moment this vapor pressure inside the container becomes equal to 1 atmosphere, it will start boiling. Now, if I look at the boiling point of water, what is the boiling point of water? We talk about the boiling point of water to be 100 degrees Celsius. The boiling point of water 100 degrees Celsius is measured at sea level. So at sea level, the pressure is 1 atmosphere. So if we go on to mountains पे जाने पे क्या होगा? What will happen if I go to the mountains? Will the pressure decrease or will the pressure increase? Will the pressure decrease or will the pressure increase? The atmospheric pressure, what will happen? Please tell me. It will decrease. Yeah. So Priya, Dishu, Amar, no man, it doesn't increase. It's a very common thing. आपने पहले भी देखा है. When you go to the mountains, you find difficulty in breathing because the atmospheric pressure decreases. So this atmospheric pressure, if decreases, what will happen to the boiling point? Now we require less vapor pressure to match with the external atmospheric pressure, and so the vapor pressure, the requirement, since is less, the boiling point will also be less. So if you take a person who is living on the mountains and boiling water and ask him that कि boiling point उन्होंने कितना measure किया, he will say that he has measured the water to boil at somewhere about 70 degrees or 75 degrees. But when the same person goes on to the sea level and measures the boiling point, he'll measure it as 100 degrees Celsius. ठीक है? So let's talk about what happens when we add a non-volatile solute. When we add a non-volatile solute, the vapor pressure decreases. Okay? Vapor pressure decreases. For example, you take water and you add some sodium chloride, table salt to it. जैसे आप table salt डालते हैं, उसका vapor pressure decrease कर जाता है, and you to match with the pressure which is required so as to undergo boiling, you need to increase the temperature even further. Okay, so if I just look at this, if I take water, so if I take water, it could have been possible that at 25 degrees Celsius रूम टेम्परेचर कंडीशन पे इसका वेपर प्रेशर 0.4 एटमॉस्फेयर है. ओके, फॉर वाटर द रूम टेम्परेचर वेपर प्रेशर इज 0.4 एटमॉस्फेयर. बट व्हेन यू टेक वाटर प्लस salt at 25 degrees Celsius, what will be the vapor pressure? The vapor pressure will be equal to 0.3 atmosphere. The vapor pressure will be equal to almost 0.3 atmosphere. Since यहाँ पे decrease हो गया 25, vapor pressure to go from 0.4 all the way to 1 atmosphere requires 100 डिग्री सेल्सियस. ठीक है, 0.4 से आपको 1 पे लेके जाना है एंड आपको क्या करना पड़ेगा, टेम्परेचर इंक्रीज करना पड़ेगा. मोर वेपर्स नीड टू बी क्रिएटेड एंड जिस टेम्परेचर पे जाके इतना वेपर्स बन जाए सो दैट इट विल बिकम इक्वल टू 1 एटमॉस्फेयर, दैट विल बी 100 डिग्री सेल्सियस. नाउ फॉर दिस टू गो ऑल द वे टू 1 एटमॉस्फेयर, you see the difference has increased. So what will happen to the temperature? What will happen to the temperature? ये temperature हो जाएगा कुछ 115 degree Celsius. So you have to increase the temperature even more so as to create enough vapor so that it becomes equal to 1 atmosphere. So that is the reason the moment you add some salt, a non-volatile solute to water, the boiling point will increase. Clear? So on addition of a non-volatile solute, the vapor pressure decreases and therefore to boil the solution, the required temperature will be higher. The required temperature will be higher. Vanshaj, sir, what if we reduce the volume? Whose volume are you trying to reduce? Whose volume are you trying to reduce? If you reduce the amount of water, that does not change its boiling point. Okay, so you take 10 ml of water or you take 100 ml of water, both would boil at the same temperature. Okay, both would boil at the same temperature. So let's talk about when would we measure the boiling point. We will measure the boiling point when we have this solvent liquid and vapor equilibrium. When we have this liquid and vapor equilibrium. Clear? And if we observe this graphically, then what you can see over here is that if we plot vapor pressure versus temperature, so at a lower temperature you can see that you have a vapor pressure value which is exclusively for solvent. But the moment you increase temperature, अब temperature increase करेगा, आप देख रहे हो कि vapor pressure क्या हो रहा है, decrease कर जा रहा है. The vapor pressure is decreasing. Since vapor pressure is decreasing, the temperature at which boiling takes place, increases. Clear? So आपका vapor pressure हर point पे आप देख लीजिए, जैसे आपने solution बनाया, the vapor pressure is decreasing and so you are moving in this direction and your boiling point is increasing. Clear? So this is the graphical way of, so boiling point of solvent, boiling point of solution. This is given in NCERT as well. इसको एक बार अच्छे से पढ़ लीजिएगा. Okay? So at boiling point, what will happen? The vapor pressure of solution will be equal to the external atmospheric pressure. Vapor pressure of solution will be equal to external atmospheric pressure. Clear? Let's look at the mathematical way to calculate this extent of elevation. कितना elevation होगा? How do I know that? The formula is very, very simple. I am giving you the simplest way to express that. I know that elevation of boiling point is a colligative property and it depends on the molality. So the elevation delta TB represents the elevation. It represents the elevation. Elevation is proportional to molality and if I remove this proportionality, I will use a particular constant which is known as ebullioscopic constant or molar elevation constant. Okay, this is the formula that you have to remember. There are a lot of ways this formula is expressed, but remember this concise form of it. You know how to calculate molality. You know how to calculate molality. Okay. So it has been observed that somebody is asking why molality, because it has been observed to be dependent on molality. Okay, it has been observed to be dependent on molality. It's not that we cannot use any other concentration term. We can convert this molality into something else as well. Okay, we can convert, since it is depending on molality, it will depend on molarity as well. अगर मुझे molarity दे दिया गया है, can't I calculate molality? Yes. So it depends on the nature of solution. It depends on the concentration of solution. If it depends on the concentration, the simplest concentration term, so as to make the formula as concise as possible, is molality. Okay, clear? So if m is equal to 1, then del Tb is equal to Kb, and if we calculate the unit of Kb, then Kb's unit will be kg Kelvin per mole, or degree Celsius kg per mole. Okay, degree Celsius kg per mole. Thermodynamically also Kb can be calculated, and to calculate it thermodynamically we need to remember this formula. This is generally not used. In this formula, R represents gas constant, which is 8.314 joule per Kelvin per mole. Tb represents boiling point of solvent. M represents mass of solvent in kgs. Okay, and delta H, vaporization, represents enthalpy of vaporization. Yeah, geek, sir, can we say that the elevation is dependent on the solute? Yeah, man. If it is dependent on molality, that means it depends on the concentration. Conversely, it depends on the amount of solute that you are having. Okay, so let's try to solve a question using this. Question is, what is the molality of an aqueous solution of glucose if the boiling point of solution at 1 atmospheric pressure is 101.27? The molar elevation constant of water is 0.52 degrees Celsius. Okay, molar elevation constant is 0.52 degrees Celsius. Celsius kg per mole. How do we calculate this? Please try to calculate this using the formula. The formula that we have to use is del Tb is equal to Kb times molality. Kb times molality. So del Tb kitna hoga? What is the boiling point of water? Boiling point of water is 100 degrees Celsius, but this liquid is boiling at 101.27 degrees Celsius. So elevation is 1.27. Okay, and Kb value is given as 0.52. This will be molality M. So what will be the value of M? 1.27 upon 0.52. What is the answer to this? What is the answer to this? कितना आ रहा है बताइए? 2.44. चलो, cool. 2.44 M is the molality. 2.44 M is the molality. Very simple question. सिर्फ फॉर्मूला देख को याद रखिए एंड वैल्यूज फिट करते जाइए. ओके, सो द सॉल्यूशन इज आल्सो हियर. मोलालिटी इज Tb by del Tb by Kb. So 1.27 divided by 0.52, this will turn out to be 2.4 molal. Next question. 18 gram of glucose is dissolved in 1 kg of water in a saucepan, and At what temperature will the water boil at 1.013 bar? Kb for water is given as this, molar mass and Tb is given as this. Okay, try to calculate, कोशिश कीजिए कैलकुलेट करने का. कैसे कैलकुलेट करना है? Tb is given, Kb is given, mass of glucose is given, amount of water is given. So first we have to calculate del Tb, which is Kb times molality. Kb value is given as 0.52. What will be molality? Okay, what will be molality? Molality will be 18 upon 180, which is the number of moles, divided by the mass of solvent, which is 1 kg. So 0.52 times 0.1, this will be 0.052. Okay, so del Tb is 0.052. So water which was boiling at 100 degrees Celsius will now boil at boiling point of solution will now become equal to 100.052 degrees Celsius. Okay, 100.052 degree Celsius. Clear? So very easy question. Kelvin में अगर convert करना है, then you can convert it also very easily. This is 0.052 Kelvin. So difference that comes in Kelvin or difference that comes in degree Celsius does not need to be changed. So this difference must be added to the temperature boiling point in Kelvin, and you'll get that new boiling point in terms of Kelvin. Next question. What elevation in boiling point of alcohol is to be expected when 5 gram of calcium carbonate molecular mass is 100, is dissolved in 100 gram of ethanol, okay, so please let us know, let me know what is the answer. Start. Okay, but getting into eclairware is one thing and working hard during the whole process is one thing. Okay, आप किसी कॉलेज में चले जाओ और मेहनत ना करो, उससे कोई फ़ायदा नहीं होता है. कॉलेज कैनॉट डू मच, यू हैव टू वर्क हार्ड. ओके, यू हैव टू वर्क हार्ड. सो द आंसर दैट यू आर गेटिंग, मोस्ट ऑफ यू आर सेइंग ए. चलिए, वेरी गुड, द आंसर इज ए. देखते हैं. Let's see the solution. Yep, your molality, if I calculate molality, I will calculate it like this, and we get the elevation value as 0.575. Okay, very good, very nice. Let's talk about an important phenomenon which is associated with boiling. Let's talk about an important phenomenon which is known as distillation. कि distillation होता क्या है? आप लोगों ने बहुत बार देखा होगा कि डिस्टिलेशन चेंबर, इफ़ यू हैवंट सीन इन योर लैबोरेटरी, यू मस्ट हैव डन एन एक्सपेरिमेंट. बचपन में कभी अपने लैबोरेटरी एक्सपेरिमेंट अगर कभी किया होगा या फिर देखा होगा, देन दिस इज व्हाट अ डिस्टिलेशन apparatus looks like. In this distillation apparatus, what we do is we take a mixture of two liquids, put them in a container, heat them, some vapors come out, these vapors get condensed and they are collected in a flask. Okay, so this process of distillation is very, very important in separation of two liquids with different boiling points, isn't it? बताइए. So distillation is a process separating the components or substances from a liquid mixture. Okay, liquid mixture. So when we take two liquids which have two different boiling points, we expect the liquid which has a lower boiling point to evaporate out or to distill out. Okay, to distill out. Yeah, Anirudh, if you have any doubts, please let me know. So, in a process of distillation, what happens is that a mixture of two liquids, let's say मैंने दो liquid ले लिया है, I've taken benzene whose boiling point is I assume that it is 60. I don't know what is it. Okay, I'm just taking an assumption. और इसको toluene के साथ मैंने मिला दिया. And toluene का boiling point 70 है. Okay, toluene's boiling point is 70. When we boil these two liquids together, then what do you think will be collected out? Whose vapors will come out? किसके vapors बाहर आने चाहिए? Whose vapors should come out? Yeah, they are volatile, they are liquids. All liquids are volatile to some or the other extent. Benzene has a lower boiling point. Benzene will evaporate to a greater extent, will create more vapors, and it will come out, and benzene will be collected over here. Okay, but लेकिन होता क्या है ना कि in a single cycle of experiment, we do not get pure benzene. We get some vapors of benzene, we get some vapors of ethanol, we get some vapors of toluene as well. So we will not get 100% benzene in just one experiment. We have to repeat this experiment over and over again. बहुत बारी करेंगे, इसको लिया, फिर से experiment इसको distill किया, and then we end up getting 100% benzene. Okay, is the benzene, so benzene will create more vapors. Functionally, benzene should become what is known as distillate. Distillate जो वो होता है जो यहाँ collect होता है, and toluene should be the residue. Okay, toluene is the residue. This phenomenon, is it pure after 2 times? No. Let's look at it. Okay? After how many cycles it will become pure? So to understand this, I will explain you how the process of distillation works. Okay, this is not given in NCERT or is not taught by, no matter आप किसी भी चैनल को उठा के देख लो, किसी भी जगह भी पढ़ाया नहीं जाता है. Let's try to learn it on Vedantu. So how do we learn it? The way to learn it is by understanding a very simple idea, very simple idea, that if vapor pressure is more, then boiling point will be, क्या होगा? If vapor pressure is more, boiling point will be less. Vapor pressure will be more, boiling point will be less. So if vapor pressure is more, boiling point is less, I'll use this concept to solve this idea or understand this idea behind distillation. Okay, so let's take two liquids. A and B. I take a mixture of liquids A and B. Okay, let's take two liquids A and B. It's given that P naught of A is, assume that P naught of A is just given as more than P naught of B. What does this tell us? That pure A liquid creates more vapors compared to pure B liquid. So what will be the relation of their boiling points? इनके boiling point की क्या relation होगा? So boiling point of A will be less than boiling point of B. Okay, boiling point of A will be less than boiling point of B. Is that understood? If that is understood, let's understand this plot. Suppose on this point on the x-axis, I take the mole fraction of A as 1. Okay, fine. Mole fraction of A is 1. Mole fraction of B, let's say, is 1. I've mixed two solutions. I've mixed two liquids. One of the liquids is present in pure quantity over here. One of the liquids is present in pure quantity over here. And if I take any intermediate point, यहाँ पे mole fraction of A will have some value. Mole fraction of B will also have some value. So over here there is in this point there is a mixture. In this whole region there is a mixture, but at this end we have pure A, at this end we have pure B. Okay? We'll talk about azeotropes a little later. Okay, we'll talk about azeotropes a little later. Let's talk about what is the vapor pressure of A. Vapor pressure of A is given as more than B. So the boiling point, we will plot boiling point with respect to mole fraction. We are plotting boiling point with respect to mole fraction. Vapor pressure of A is more, so boiling point of A will be less. Boiling point of B will be more. So this is T naught B for A. This is boiling point of B. Okay, this is boiling point of B. Now remember, vapor pressure versus mole fraction is a straight line plot, but boiling point versus mole fraction is not a straight line plot. The plot goes like this. The plot goes like this. It's like, okay, it's like a curve. And we would see something like this. Okay, we would see something like this. Because of the mathematical equation, which we are not going to discuss right now, we will see something like this. So it's like a leaf. Okay, it's like a leaf. Clear? Now, what happens when we start boiling something? Let's say I take a container which contains some amount of some solution which has A as B as well as B simultaneously present. I start boiling. Remember that the lower one is known as the liquid curve and this is known as the vapor curve. Okay? This is known as liquid curve, this is known as the vapor curve. इसका meaning मैं आपको अभी समझा दूंगा. So what happens if I take a liquid, let's say this is point M, I start boiling a liquid at point M. What will be its boiling point? Boiling point will be Tm. When a liquid starts boiling, it will create vapors at the same very temperature. That means it's a isothermal process. Same temperature पे vapors create होते हैं. So at the same temperature, some vapors will be created and we will follow. What we will do is, we will see that this temperature Tm, where does it bisect? If I take a line perpendicular to this concentration thing, where does it bisect the vapor curve? Okay, where does it bisect the vapor curve? This is the vapor which is created. Now I condense the vapor and collect it as a distillate at point N. I collect it and I obtain a distillate at point N. So अब देखिए, ये आपने boil किया. These are the vapors and this is the distillate. So you're not getting pure A at one go. What happens? You are getting some intermediate composition. You are getting an intermediate composition. Okay? Hitesh, when you are not talking about the subject, लेट्स नॉट डाइवर्ट फ्रॉम इट. ओके, आपका क्वेश्चन है किताबों पे, वो हम लेक्चर के बाद भी ले सकते हैं. ओके sir, so Tm should decrease. I'm not saying Tm should decrease, I'm saying that any liquid with a given composition has a specific boiling point. When you boil it, it will create some vapors which when you condense will not even give pure liquid at one go. So you will get a liquid at point N. So the composition is this. This is a new composition of the distillate. So this is the distillate. This is the distillate. What I do next, I boil this liquid again, and this boils at Tn. I condense this, I obtain a solution of composition O. You are seeing that the distillate is slowly moving in composition towards A. The distillate is slowly moving in composition towards A because, which is very, very obvious. When we have two liquids, A and B, and we distill it, which should be distilled out first? The one which has lower boiling point. So our pure distillate should be preferably A. So what you can see that in all the distillates, the concentration is moving more towards A and less towards B. Okay, I'm sorry this just went away, but this is how it happens. Okay, because the concentration increases, so we have to repeat the cycle over and over again. Until this distillation process yields pure A. Clear? So with this we end today's lecture. In the next lecture we'll talk about depression of freezing point, which is very, very useful in like a number of places, and we'll continue from here. So please do let your friends know that we are conducting these classes, and please do take help from these. Try to solve as many questions as possible, and that will be all. Okay, easy chapter, जितने questions solve करोगे उतना easy रहेगा. Okay, चलिए guys, all the best and bye bye.